So today we will see a different approach to solve the convolution problems. Okay, this is called as this is the shortest method possible, but most of the time it is not considered as a standard. Okay, that's why we never considered this problem at first. Okay, so this was the given data. Let's now we need to make a table basically. So the length of any one of the signal will become the number of rows in the table, and the other signal you can make it as a number of columns. Okay, so I'll just find out what is the length of each of the signals. So L1 first length is equal to 1, 2, 3, 4, 5. So there are 5, right? So second one I'll call it as L2, and this is how much? 6. 1, 2, 3, 4. So mistake. So only 4. So I'm going to make a table with the 5 rows and 4 columns ultimately. Okay. So just we found the lengths only for that. Okay. So I need a table. So let us directly draw it. So I have to have 5 rows and 4 columns basically. Okay. This is row number 3, row number 4, and 5. Right. Similarly, let us draw 4 columns now. Column number 1, 2, column number 3, and column 4. Okay. So what you do, you write the signals accordingly. I'll write the x of n on the top, so that is 0.5 minus 1.25. Oh, okay. So it should be h, right? So x is, I told x as the column, so let's make a change. Okay, so just make that change. Write x of n vertically because there are 5 rows, right? Okay. So this is 0.5 minus 1.25, 2.5 minus 3.75, and 1. Other signal you write on the in this fashion, okay, along the columns. So this is minus 1.8, 2.15, 8.96, minus 7.67. Okay, so let me know once you have reached till here, then we'll fill it together. In the next step, I want you to multiply both the numbers and fill it here, right? So like minus 1.8 into 0.5 will be minus 0.9. Okay, like that. You keep filling the whole table. Once you fill, let me know. We'll proceed further. Okay, so after minus 0.9, 1.075, right? Okay, okay, then okay, 2.6875 negative, 10.9312. Okay. Mm, okay. 9 point, this is 5875. Okay, minus 4.5, 5.375, 22.4, 19.175, 6.75, 25, minus 33.6, 28.7625, minus 2.7, right? 3.225, 13.44, 11.505. Okay, normally, right, whenever two signals are given, make this table first step. The second step is I have to take the sum. The sum has to be taken along the diagonals. What do you mean by the diagonal? It's in this way. Start from the topmost top left corner where you have only one right entry, right? This is the top left corner. So always you have only one entry over here. So always your answer starts from that particular cell of the table. Okay, so I'll put an arrow mark, right, just for your reference. So this is what I want. I want you to add, if whatever numbers that come, I want you to add. So in this case, it is only one number. So the first answer is, I'll write here, that is just minus 0.9. Anyway, we'll verify this answer later. Okay, by running the code itself. Okay, we have written a code already. Okay, then the next entry will be the second, what do you call, the the one diagonal below that, right? So that should be something like this, but you need to add both the entries. Okay, so add 2.25 and 1.075. Okay, so that is 3.325. So, right, next one. The next answer will be coming along the diagonal which is present below the diagonal which we considered just now. So that should have three entries now. Okay, so these three numbers you just add to get the answer. That is minus 4.5, minus 2.6845, and 4.48, minus 2.7075. Okay. Similarly, let's move to the next uh, diagonal. So that is about this. So add these four numbers. Minus 2.6412. Next, let's move further. The next diagonal should be considered now. So that is starting from, okay. So all these numbers, you again four numbers. 21.225. Okay. Then move on to the next one. So that is along minus 49.55. All right, then two entries along this pattern. 42.2025. All right, and the last one, it's minus 11.505. Okay. So this is minus 11.505. So y of n actually begins from here. So it's in this way. So this is the first entry, then the second, third, fourth, fifth, sixth, seventh, eighth. Now actually I'm getting right starting from zero, right? I think one, two, three, starting from zero till seven, correct? So y of zero to y of seven. That is obviously right? I'm getting 8 points. So is it justified? Can you justify I'm getting 8 points and it is right? Right? It is because L1 plus L2 minus 1. 5 plus 4 minus 1 is how much? 8. So I'm expecting length 8 sequence, and yes, I can see that, right? I am getting a length 8 sequence. So, but before that, we have to verify this by running the code in MATLAB. All right, so let's just verify whether the code we have written already, right? Is it going to give you the right answer? Okay, so let me just write this. So it's asking enter the first sequence. Okay, so the first sequence is 0.5 minus 1.25, 2.5 minus 3.75 and 1.5. It's asking to enter the second sequence. So this is minus 1.8, 2.15, 8.96 minus 7.67. All right, so let's check this. So you can see minus 0.9, 3.325, minus 2.7075. That's what you got, right? Then minus 2.91. Just verify that answer one. Okay. The fourth sample you need to verify because the program says it is minus 2.91 and you got minus 2.6412. Please check that. Then 21.225 minus 49.55, 42.205 minus 11.505. That's right. Only except 1 point. You can see that, right? Everything matches. All right, please verify this 1 point. Okay, I think there is a small mistake. Let's correct that. So this entry is not minus 10. Instead of that, it has to be minus 11 point something. Is it 11.2? Okay, let's correct. All right, so that means this is minus 11.2, correct? All right, now, so because of that change, now I think we can correct the result. Okay, so this changes to minus 2 point minus 2.9, right? So minus 2.9. Okay, 9, right? Okay. So I'll give a problem to solve now. It's just I'll give a simplest one. So minus 1, 1, 0, 2, minus 3. First sequence. Second sequence is 1, minus 3, 2, 0, minus 4. Perform the convolution x and h and give me the answer y of n. Okay, use this the latest shortcut method. Okay, then we'll verify the answers. Y of n is minus 1 plus 4 minus 5, 4 plus 9. Okay, 1, 2, 3, 4, 5 plus 4, 9. Yeah, expected length is 9. Okay, now let's verify the same thing in So let's enter the sequence number 1, that is minus 1, 1, 0, 2, 0, 2, minus 3. Second one, 1, minus 3, 2, 0, minus 4. Okay, just verify everything. So it's minus 1, 4, minus 5, minus 5, 9, minus 6, minus 8, and 12. Perfect. All right, so that's all about a one-dimensional convolution. All right. Now, let us move further. So our next objective is actually an application level, something like when we go for image processing or something related to image or even the deep neural networks, right? They are having a particular layer called as convolution layer, which performs a two-dimensional convolution. 2D, 2D convolution. Right. So instead of using the two signals which are uh, one dimensional, okay, so what we are trying to perform here is we take two signals which are right two dimensions, which are in two dimensions, right? They are considered to be two-dimensional signals, and we will perform the convolution of two-dimensional signals basically. Right? So let's try to look at the equation first. So if I want to write the convolution of two signals, okay, so let me write two dimension in the sense I'm going to get y of m comma n. This is equal to, how do I write? I write x of m comma n convolution h of m comma n. Previously there was only one variable, x of n, h of n. You convolve to get a y of n because only one dimension, isn't it? Now it's different. That's why it's in this way. Now let us try to write. Now since there are two dimensions, you need to write two summations. One summation is for x axis, one more summation for y axis. So the index for y I'll write outside. So that is j is minus infinity to plus infinity, right? The index for x-axis I'll write I is equal to minus infinity to plus infinity, right? So write it in this fashion. So I'll write, keep one of the function fixed, correct? So that is x of I comma g. And what you're supposed to perform now, the second function should, the second function, but whatever you are going to write, right? So that has to be shifting, that has to shift, correct? Shift and flip. So how do you write that? So that will be performed in this fashion. So I'll write this is m minus I, right? Like n minus k, right? Same thing. This is n minus j. I and j are the shift, I along x-axis, j along y-axis. You have to repeat this to get your final answer, that is y of n comma n. So in this case, you see, it's very hard to write a table or something like that. We don't do any table or something. We keep writing the answers, right, in a straightforward fashion. Okay, so let's go for an example first. Okay, so just keep this equation in mind. So we'll do this. So let's say we take signals like this. Say so x of m comma n. Let's try to write a matrix. This is the matrix. This is the first signal, which we try to keep it as fixed. Okay, so let's try to write it in the matrix form. Okay, 1, 2, 3, 4, 1, 2, minus 1, 3. This is 3, minus 1, 2, 0, 1, 3, minus 1, and 2. So it's a 4 into 4. 4 rows, 4 columns. That's the first function, first matrix. And take h of m comma n as this is 1 minus 1 minus 2 and plus 3. All right. So my answer actually begins from, right, starting from, see, my idea is this. Consider that the h of m comma n is inside this particular square. Okay, so what happens? I move this h of m comma n over here first. Okay, this is the first position. I calculate. I get an answer. I call it as y of, right, m comma n. Then I move it to right. You see, only I changes. J is fixed. So J is initially fixed. Only I keeps on changing. Calculate this. Then increment J, change I once again. Calculate this. So that's the algorithm that we are doing there. Okay, right. So keeping that in mind, so this is how we calculate. Let's try to do this. So it's a point by point multiplication. You have to perform a dot product. Okay, right. So it's a point by point multiplication. When I keep this over here, right, what the points you are multiplying, this 1 into 1 plus 2 into minus 1 plus 1 into minus 2 plus 2 into 3. That's what is your first answer. Okay, the result, first point on your result. I hope that point is clear. Correct. So anyway, let me write that. Right. Yeah, yeah, sure. Now, so just see here. Uh, my first sample, I'm trying to write y of 0 comma 0 possibly. Right. So that is nothing but I'll just write here and let me, y of m comma n is what I want to calculate. So what you do, you move this h, right, starting from the top left corner of your given sequence x. So multiply point by point. That is 1 into 1. First point into the first point, right? Plus 2 into this, plus 1 into minus 2, plus 2 into 3. Right? So that will give you the first sample in your answer. This has to be repeated several times now, as much until and unless you finish the every points on your given x, right? You have to repeat this. Okay, anyway, let's do that together. Let's do the first multiplication, first convolution point. So what's the answer for that? So let's simply write this. So the first step is nothing but I'm bringing this over here. That's all. Okay, assume that h of m comma n is exactly overlapping with these points, these 4 points. Okay, and multiply the point by point, and take a summation and write the result. That's what we want right now. Okay, so that means my multiplication happens in this way. That is, first sample into first one, that is 1 into 1, plus second one, 2 into minus 1. Then the third sample is plus 1 into minus 2 and plus 2 into 3. Let me know if you have any doubt. So this is actually 1 minus 2 minus 2 plus 6. So 6 minus 4 is plus 2 plus 1. So this is equal to 3. Are you okay? Okay, anyway, actually you don't have to do this. This is, if I try to write this, then I have to give a name like y of 1 comma 1 and so on. Okay, so anyway, let me write that. Later on, we'll convert this into the required answer. Okay, so in the matrix format, we can write it later. For the time being, let me write it in this way. This makes it more clear to you what exactly we are calculating. In my y, I'm calculating 1 comma 1. Next, I'll shift to right by 1 unit. So this is y of first row, second answer. Okay, so that means what I'm supposed to do, bring this over the second position, one shift. It shifts to right by 1 unit. Are you okay? So that means, right, I have to do the calculation in the very similar fashion. So this is 1 into 2, 2. plus 3 into minus 1, minus 3. 2 into minus 2, minus 4. Minus 1 into 3 is minus 3. So is it minus 8? Okay. Similarly, proceed further. Calculate y of 1 comma 3. That is 3 minus 4 plus 2 plus 9. I think this comes as a plus 10. Just verify. Now, so we got y of 1 comma 3, right, which was a result of the h of m comma n overlapped over here. Now just think what happens if I shift this right by one more unit. It's like this. I don't know what is there, right? So I cannot do the confusion, right? So you stop that process here. You go to the next overlapping position, next valid overlapping position on the x, right, which is nothing but this position. Can you see? This is next valid position. So this is going to generate our answer, and that answer, let us try to denote that as y of, now you see it's a second row position, so 2 comma 1, right? So that is 1 into 1 minus 2 minus 6 minus 3. So minus 10 I guess. Just verify once. Okay. Then we have y of 2 comma 2, same thing, shifted to right and overlap it over here. So 2 into 1, 2, minus of minus plus 1, minus of minus plus 2, 2 plus 3 is plus 6. This is plus 11. All right. Then y of 2 comma 3, right, overlapping it over the last possible valid position on the second row, right? So that gives how much? This means it is equal to, so 1 minus 1 minus 3 minus 4 and 0, right? That is minus 8 I guess. Y of 2 comma 3, then move down 3 comma 1. So that is 3 plus 1 minus 2 plus 9. 11 I guess. Just verify. Okay. Then y of 3 comma 2. This is minus 1 minus 2 minus 6 minus 3 minus 12. Then we have y of 3 comma 3, right? So that is 2 plus 0 plus 2 plus 6, so 10. So this means we can write our answer. So therefore y of m comma n is equal to, copy every point in the respective position. So 3 minus 8, 10, minus 10, 11, minus 8, so 11, minus 12, 10. So this is the result of a two-dimensional convolution. All right, so process is pretty simple, right? I don't have to perform any tabular calculations like what we did in the one-dimensional thing. But, right, in order to understand this process, that is absolutely necessary, right? What exactly is happening, we can identify and understand. Okay, right. I'll give you a problem to solve. So the next problem is this one. Okay, this is x of m comma n. It's a 2D function. Okay, so this is a 3 cross 3 matrix. Second one, and the first one is a 5 into 5.